Okay, so this is Unit 4, Objective 8, Homework Help for Graphing Radical. So this is, I'm on page 490, which is the part of your homework. So page 490, Graphing Radicals. So let's take a look at question number 3. So for question number 3, I know that this says x plus 6, so the 6 is affecting the x, so that means I need to shift left 6, right? So I'm going to go left 6. So let me just draw in my xy here, give myself enough room. So from here I'm going to go left 6, so 1, 2, 3, 4, 5, 6. Okay, and then if I were to plug in, different numbers to figure out, okay, give me a couple more dots here. So I always want to plug in 1 to the right, so I'm going to plug in -5. So plug in -5, so -5 plus 6 is 1, and the square root of 1 is 1. So that means I go 5 and 1. Right, and so now I'm thinking, okay, so what are some other numbers I know the square root of? So I know the square root of 1, and I also know the square root of 4. So I'm going to plug in -2, right? So -2 plus 6 is 4, so the square root of 4 is 2. So -2, 1, 2. Okay? And then there's my graph. Okay, so that was question number 3. And then sorry. Okay, and then let's take a look at question number 5. So for here, I know that this is the same as y plus 1. Right, so add 1 over. So that means I'm going to go left 2 and down 1, right? So left 2, down 1. So x plus 2, because that's affecting my x, so I'm going to go left 2 along the x-axis. This is affecting my y, so I want to go down 1. So left 1, or excuse me, left 2, down 1, right? I always want to plug in one number to the right, so I'm going to plug in -1. So here, so I'm going to have 1/2, and then -1 plus 2 is just 1, and then -1. So half of 1 is 1/2 minus 1, which is -1/2. So that means I'm going to go -1, -1/2. And then another number I know the square root of is the square root of 4, so that means I'm going to use x is 2. So I have 1/2, 2 plus 2 is 4. So the square root of 4, run out of room here. Square root of 4 is 2, so 1/2 of 2 minus 1. So half of 2 is 1, minus 1 is 0. So when x is 2, my y value is 0. So then, it's not a very good graph, but so something like that. Okay? All right, and then let's take a look at worksheet 8. So that was the bookwork stuff. Okay, so let's look at question number 2 on worksheet 8. So I'm going to do this on a separate piece of paper. So for question number 2, I'm going to rewrite g of x because I want to have my radical first. So that would be -√x and then plus 5, right? So when I look at that, I can see that the plus 5 is not associated with the x, so therefore it's associated with the y. So I'm going to subtract it over. And then as far as my shift go, there's no horizontal shift because nothing is affecting the x, but then there's a vertical shift, right? So instead of going down 5, I would go up 5, so I know it's just shift of up 5. So then I'm going to go ahead and graph it. And then I want to do a t-table. I always want to plug in one number to the right. So I'm going to plug in to the right of that would be 1. And then I'm going to the original, so negative square root of 1 plus 5. So square root of 1 is 1, so that would be negative 1 plus 5, which is 4. So I'm going to go over 1 and then up 4. And it should be lower, right? Because if it's a negative root, that means it's going to go down like that. Okay? And then what else do I know the square root of? I know the square root of 4. So if x were 4, I can work that problem out. So that would be negative root 4 plus 5. So that's negative 2 plus 5, which is 3. So over 4 and then up 3. So somewhere around there. Okay, so there's my graph. I always want to do our graph first, right? Let me zoom out a little bit so I can see what I'm doing here. Okay, so now let's go ahead and answer our questions now that we have the graph. So for our domain and range, so domain is the x values. So I'm starting at 0 and then going forever to the right. So starting at 0 and forever to the right. So bracket on the 0 because it equals and it can't equal infinity. And then for my range, we go bottom to top. So left to right on domain, bottom to top on range. So although it doesn't look like it, it's going down forever, just very slowly. So because it's going down forever, that would be negative infinity. And then if I look here, this is stopping at 1, 2, 3, 4, 5. So it's never going above 5, right? And equaling 5. So down forever, even if it doesn't look like it, and then up to 5. For part B, I want to find my x-intercept. So where does it cross the x-axis? So if I want to solve for x, that means I let y equal 0. So here I'm looking up here, so y equals 0. Oops. So 0 equals negative root x plus 5. So I'm going to subtract 5 to the other side. Or I could add root x, right? Divide by negative 1. And then square. So then my x-intercept is at 25. And then for my y-intercept, I don't need to solve because I can look to see that it crosses the y-axis here. So then that would be at 0, 5. Okay. All right, and then let's see, part C was the y-intercept. Okay, and then part D, I want to see where are we decreasing. So where are we decreasing? And if I'm looking at my graph, it's decreasing always, right? It never goes up. So from left to right, it's always going down. So it's decreasing on its domain, which is from 0 to infinity. And then here I want to know where is my graph negative. So when I say where is it negative, I mean where is it below the x-axis. So where is it down here? Well, if I look, it looks like it's never down there. But if I remember, I found out my x-intercept was at 25. So way out here somewhere, I don't know, so we'll call this 25. The graph will eventually hit here and then go below it, right? Because the x-intercept meaning it crosses the x-axis, and when it crosses the x, it will drop below. So where is it negative? Past its x-intercept, which is past 25. So it's actually not negative at 25, but everywhere past 25. So from 25 to infinity, right, it's below the x-axis. And so parentheses at 25 because it's not actually negative there. Okay, let's do one more here. Let's do question number 4. So for number 4, we want to graph this before we do anything else. Slide this up a little bit. So I'm going to add the 2 to the other side. So the plus 1 is affecting the x because it's grouped with it. So that means I'm going to go left 1. I put the plus 2 in the right place, right? The straggler number needs to go with the y. So that means the plus 2 is affecting the y. So that means I'm going to go down 2. Okay, so let's do a graph. So left 1, down 2. Okay. And then I'm going to do a t-table over here. Always plug in one number to the right, so I'm going to plug in 0. So then I'm looking at my original problem here. So that's 1/2. And then 0 plus 1 is just 1. So half of 1 is 1/2. And then that would be 1/2 minus 2, which is negative 1 and 1/2. So over 0, down 1 1/2. And then what else do I know the square root of? I know the square root of 4. So x would then be 3, right? Because 3 plus 1 is 4. So then I have 1/2 of 4 minus 2. Or square root of 4, I said that wrong. So 3 plus 1 is 4. So square root of 4 is 2. So half of 2 is 1 minus 2, which is negative 1. So over 3, and then down 1. So like that. Okay. Alright, and then for part A, they want domain and range. So domain is left to right, so it starts at negative 1, goes to infinity. Range is bottom to top, so the lowest it goes is 2, right? It doesn't go below 2. And then even though it doesn't look like it, it's going up forever, so to infinity, right? And for our radicals, remember that always one of these should be infinity, right? Either this or this is infinity, that or that is infinity, depending upon our translations and reflections, right? Okay, and then for part B, they want the x-intercept. So the x-intercept, we can't tell by looking at the graph. So I'm going to let y equal 0. And then, so I'm just going to go from here. So if y is 0, that would be 0 plus 2. And then now I have to solve for x. And so in order to solve for x, I need to get rid of the numbers outside. So I'm going to multiply by 2 over 1, which is the same as multiplying by 2. Then I'm going to square both sides. So that would be 16, and then equals x plus 1, and then subtract 1. So my x-intercept is at 15. Okay. And then for part C, my y-intercept, I can tell by my graph that it's right here, right? And that was when x was 0. And it was down at negative 1 1/2, right? And that was off of my t-table here. And then for part D, we want to know where is my function increasing. So if I look here, it's always going upwards. So it's increasing for its whole domain, which is right here. So it's increasing along its entire domain. So from negative 1 to infinity. Okay, so for part E, I want to find the average rate of change. So remember, for my average rate of change, I'm going to set up, and so for x is 3 and 15, I want to find the corresponding y values. So I'm going to replace x with 3. And I know from up above, I already solved for it, so I'm not going to do it again. So I'm just looking, okay, I solved it up here. And then now I'm going to do the same thing again, but now I'm going to do it for 15. So replace x with 15. Again, I'm looking at the original problem. So 15 plus 1 is 16. And the square root of 16 is just 4. Half of 4 is 2. And then 2 minus 2 is 0. Okay. So now that's just showing my work, right? So what I want to do is I want to write these as an ordered pair so I can make more sense of this. So when x was 3, my y was -1. And when x was 15, my y was 0. So when I plugged 3 in, substituted 3 in, I got -1. When I substituted 15 in, I got 0. So now for my average rate of change, I subtract my y, so from -1 minus 0 over 3 minus 15. And I could have subtracted the other way, right? I could have done 0 minus -1, 15 minus 3. So -1 minus 0, 3 minus 15, and that's just the same as 1 over 12. And that's my average rate of change or average slope.